Let's talk some more about similar shapes. We've covered similarity before, but it's a big topic, and there's some important aspects that students sometimes have trouble with. So let's spend a little bit more time going over the concept. Being similar basically means having the same shape, though not necessarily the same size. If two shapes are similar and the same size, we call them congruent. Congruent shapes are automatically similar. All three of these polygons are similar. The bottom two are also congruent. We can talk about the similarity and congruence of any kind of shapes, circles, stars, squiggles, but most of the time we focus on polygons, and that's what we're going to talk about here. Similar shapes can be different sizes. They can be rotated, they can be flipped over to make mirror images. Take a second and look at this picture and see how all these ideas apply. They can even overlap. This comes up more often than you might think. When two shapes are similar, each part of one shape corresponds to exactly one part of the other. In similar polygons, corresponding angles are congruent. That means they have the same measure. Here are a couple of color-coded corresponding sides of two polygons. The rules for sides of similar polygons are a bit more complicated than the rules for angles. But before we get into that, take a minute and let's do some intuition building. Look at these shapes and think about how the blue sides go together and the red sides go together. Now check out these two. Notice how one of the shapes has been not just rotated, but flipped over. Here are two similar polygons that share a common angle. This may seem a little strange at first, but it's a situation that comes up frequently, and it can be used to solve all sorts of interesting problems. We say corresponding sides of similar polygons are proportional. Unlike corresponding angles, corresponding sides don't always have the same measure. If they did, the shapes wouldn't just be similar, they'd be similar and congruent. Instead, they are proportional. That means the sides have the same proportion or ratio. There are two ways of looking at this, though they both work out to be the same way mathematically. The first approach is to divide the length of a side of one shape by the length of the corresponding side of the similar shape. We said earlier that these two polygons are similar and that the red sides correspond with each other and the blue sides correspond with each other. That means we will get the same answer when we divide 12 by 18, the short red side by the long red side, as we do when we divide 4 by 6, the short blue side by the long blue side. The other approach is to look at the ratios of lengths of pairs of sides in the same shape. For example, look at the shapes we just worked with. Since the blue corresponds to the blue and the red to the red in these two polygons, dividing the length of the blue side by the length of the red side in the large shape will give us the same ratio we get when we divide the length of the blue side by the length of the red side in the small shape.